Hello everyone and welcome to this comprehensive tutorial for Haixun Speed Design and Haixun Speed Production. In this tutorial we will cover all the features and capabilities the software has to offer, as well as the entire process of designing and optimizing our product. The software consists of two parts or segments, and in the first one, named Haixun Speed Design, we fully define and prepare our model. And in the second one, or Haixun Speed Production, we optimize the production process and generate the G-code file. The software uses USB tokens, which must be connected to the computer before starting the program. Speed Design and Speed Production each require their own token, and without them the software will not function or generate the designs and files. Once we confirm that the tokens are connected, we can launch the Haixun Speed Design. The Haixun software also requires an internet connection to work properly, so we need to make sure we are connected and then log in using our username and password linked to the token. After the software loads, we are greeted by the main user interface. To begin designing our product, we first need to prepare the material database and make sure that all of the materials which we plan to use are already added in the database. We can do this by clicking on the Material Manage option, which is located in the Basic Data subsection. After clicking it, a new window called Material appears, showing us a list of all the available materials. For the software to generate the design correctly, we must ensure that the information in the columns name, color, and thickness is accurate and valid. These values will be used during the exporting process and additional setup in Haixun Speed Production. So it's important for us to make sure that each material name is written exactly the same in both programs, including the uppercase and lowercase letters. If the material we need is not listed, we can add it manually by entering all its parameters in the fields above. Once we confirm that everything is correct, we click the Add button, and the material will be added to the list. After confirming that all the materials have been added, I'll click the X button to save the changes. Next, I'll return to the Start subfield and click the New Order button. After clicking it, a new window named Order Information pops open, in which we need to input all the necessary details for this order/design. We start by entering the name and the order number, and then we fill up the remaining information, such as the dealer name, the order date, the delivery date, and customer information. Then we need to select all the materials that we will use in this design, and we do this in the Material Information section, which is located at the bottom of the Order Information window. If we double-click on the empty field in the Material Name column, a new window named Material pops up, showing us a list of materials which we previously added in the Material Manage window, which was found back in Basic Data. To select the materials, we simply check the box in the Select column. For our project, I will use 18mm and 6mm thick chipboard. I need to select them and then click the OK button. For all structural elements, the software will use the 18mm thick board, while the 6mm board will be used for the back panels. Once selected, the materials are added to the order. Finally, we confirm by clicking the OK button, and the software displays a System Tips message indicating that the order has been successfully created. Next, we can start designing the elements. We click the New Product button in the Start section, located in the upper left corner of the interface. After clicking it, a new window named Create Product opens up, and here we have all the tools and functions needed for designing our components. We begin with the Blank Frame button, which opens up the Add Component window. Haixun Speed Design creates an empty frame with predefined dimensions, and our task is to fill that space with boards and elements and define their position and orientation. In the Add Component window, we go to the Parameter Information section and enter the frame dimensions in the param value row. In the first field we enter the width, in the second one we enter the depth, and in the third one the height of our empty frame. Once we are done, we click the OK button and the software generates the empty frame, which appears highlighted in green when selected. Next, we need to add the main structural elements, the left, the right, the top and the bottom panels. The software provides a section in the upper central and right area of the interface where we can find all panel types with different orientations. For example, the H plate button is for adding a horizontal plate or panel. The MH plate is a modular horizontal panel that can be repositioned if dowels are added in the design. The T plate button, for example, is for the top plate. The B plate is for the bottom plate. V plate is to add a vertical plate, and the L plate and R plate are the left and right plates. To add any of these elements, we simply click the corresponding button and the software places it automatically. We begin by adding the left and right panels using the L plate and R plate buttons. Next, we add the top panel using the T plate button, and before we add the bottom panel, we will use the split space function to divide the empty space into two sections. We click on the split space button and select the top and bottom option from the drop-down menu. This function divides the space into segments. We can choose to split it from front to back, from top to bottom, or from left to right. When we select the top and bottom option, we activate the operation which divides the space with a horizontal cut. In this section, we can define the margins, the offsets, and the exact point where the split will occur. For this example, I want the bottom section to be 80 millimeters high. So I select the bottom margin option and enter 80 millimeters in the field next to it. After this, I can click the OK button and the frame is divided into a top and bottom sections, which can now be selected individually. After dividing the frame, we continue with adding the elements. I select the top section of the frame which we just cut and click the B plate button to add a horizontal panel. The software automatically places it at the bottom of the selected frame. The software determines the order of the panels and their connection points based on the sequence in which they're added. For this reason, we started by adding the left and right panels first, followed by the top panel. Now, the only remaining step is to add the back panel. Haixun uses the materials that have already been added in the material database, and in our case we selected the 18mm and 6mm thick chipboard, and my intention was to use the 18mm board for all structural panels, and the 6mm one will be used for the back panels. When adding a back panel, Haixun offers us two options. The option thick B plate, which adds a thick 18mm plate in the selected area, or the option thin B plate, which adds the thin 6mm plate. In this case, we will select the thin B plate, so the software will generate the back panel using the 6mm material. To view the design from different angles, we can use the preset views located in the view section in the upper right corner of the interface. These include the default view, the front view, back view, left, right, top and bottom views. If we want to rotate the design freely, we can enable the rotation mode in two ways. First way is to click the rotate button in the upper left corner, or we can do a sequence of commands. Firstly, we press the middle mouse button and then click and drag with the left click. This allows us to freely rotate the model while the rotation mode is active. Next, We continue by adding elements to the lower section of the empty space we created using the split space function. In this area, I want to add a previously defined component from the database, specifically a support element. First, I'll make sure that the empty frame is selected, and then I can insert the element from the database. The database is located on the right side of the interface, and it contains a wide range of components including drawers, swing doors, legs, frames, and much more. For this step, we need the front and rear support elements, which can be found in plate, then system plate, and then the common brace folder. I double-click the desired element to insert it into the selected space. This opens up the Add Component window, where we can adjust the parameters and alignments if needed. All elements in the database are parametric, which means the software automatically adjusts their dimensions to fit the selected space, regardless of its size. In this case, I will add front and rear supports, also known as skirt boards. After setting the necessary parameters, I click the OK button, and the software adds them to the design. First, I'll add the rear support, called the back brace. In the Align Front and Rear section, I select the back option so that the element is placed at the rear of the frame. After clicking OK, the element is generated in the correct position and orientation. Next, I add the front support. I select the front brace, I double-click it, and this time I'll choose the front option in the alignment section. After confirming with the OK button, the software places the element correctly at the designated spot in the cabinet. Next, we can start filling the interior of the design with elements. We select the empty space, and from the panel section in the upper right area, we click on V-plate. This creates a vertical panel that divides the selected space into two equal regions. If we want to adjust its position, we simply select the panel, and while it's selected, it turns its coloring into light blue. Additionally, the software displays dimension lines which show the exact distance from the neighboring elements. To modify these values, it's best to switch to front view for better visibility. And now we can click the dimension value and enter the desired number in the small input box that appears, after which we need to press enter. The panel will move according to the new value, and additionally, while the panel is selected, the software also shows green arrows, green and red arrows, indicating the directions in which the element can be moved. These directions depend on how the panel is positioned within the design. Now that we have two separate sections, we can continue filling the interior. I select the left section and begin adding horizontal plates using the H plate button. Just like before, the software divides the selected space into two equal parts and places the panel in the center. After each division, the software automatically selects the newly created lower section. So if I click H plate again, that lower section is split once more, creating another shelf between the two spaces. In this case, I will also divide the upper section by selecting it and clicking H plate. For the lower section, I will add a predefined elements from the database, such as drawers. As before, we start by selecting the empty space where we want to insert the elements from the database. Then we navigate to the drawer folder, which is located in Cabinet, then System Module, and then the folder named Drawer. Here we can choose from several different drawer types. In this example, I'll select the drawer A. I double-click on it and the software opens up a new window called Drawers Add, where we can adjust all the drawer settings. In the first section, named Drawer, we have options such as the drawer parameters, which include the dimensions of the drawer, as well as the position of grooves and holes. These values are parametric, meaning they automatically adjust based on the space where the drawer is placed. The drawer type option controls the front face of the drawer. If we select outer cover, the drawer front extends beyond the cabinet's face. And if we select embedded, the drawer aligns flush with the cabinet. Next, under drawer number, we can enter a value for how many drawers we want to be generated. In this case, I'll choose 5 drawers. Below that, in the drawer distance field, we can define the spacing between each drawer, and in the panel section we can choose the material type, such as plastic or other options. Right below that, we have the auto height and auto depth. The auto height automatically adjusts the height of each drawer so that they're evenly filled the available space. And auto depth extends the drawers to match the full depth of the cabinet. Finally, we have a few more important settings to configure, including the drawer alignments, the supporting components, and the type of thickness of the edge banding. In the align section, we can define how the drawers are arranged, either from top to bottom or in reverse order. In the slideway section, we choose whether the drawers will use rails and whether the software should generate the necessary grooves for them. In the handle section, we can enable handles, and if needed, we allow the software to automatically create handle holes where we can mount the elements. In our case, we won't be using handles, so I'll leave this option unchecked, since the design I have in mind will use a hidden handles instead. Next, we move on to the remaining settings by clicking on the slideway tab at the top of the drawer add window. This section contains all the parameters related to the drawer rails. In the slideway length section, we can see the rail dimensions. These values are automatically adjusted by the software based on the available space. Right next to that, we can choose the rail brand, only if previously it has been added to the database, as well as we can choose the type of rail, whether it consists of 2 or more sliding components or a different mechanism entirely. In the base information section, we have general specifications such as length, width, and thickness. These values also update automatically depending on where the rails are placed. Below that, in the location hole section, we can configure all the mounting hole details, including the hole diameter, the position of the hole, its depth, and other related parameters. The next section, called handle, is where we can configure the drawer handles. In the first field, we can choose the handle brand, just like we did earlier with the rail brand. And below that, we can select the handle type, such as a single handle, a handle with 2 mounting holes, or a hidden handle. In the lower part of this section, we can define additional details, including the handle hole positions, dimensions, and overall placement. The next section is lock. If we enable this option, the software will add a locking mechanism to the design. All related settings, such as type, orientation, and position, can be configured in the lower part of this section. As before, we also have a visual preview with dimensions. I won't be adding a lock in my design, so I'll leave this option unchecked. And the final section is copper bar, which allows us to add a decorative element. In this case, it's a copper strip on the front face of the drawer. We won't be using this feature in our design, so no selection is needed. Finally, we return to the drawer section and click the OK button. The software generates all the drawers based on the parameters we've set. Next, we can fill the adjacent section of the cabinet with elements. First, I'd like to add a clothes rod, and there are two ways to do this. We can either locate it in the database. It can be found in cabinet and then system module, then cabinet parts, and we need to select the cabinet tube. Or the other way is we can select the same option from the upper right side of the interface where it's labeled clothes rod. This opens up the clothes rod add window where we can define the type, the alignment, and the dimensions. Just like with all the other elements, their values will adjust automatically based on the available space. After clicking OK, the rod is generated inside the cabinet. For better visibility, I switch to front view and rotate the model to get a cleaner look. To reset the view, I simply select the default option in the view section. Next, I'll add another type of component. We navigate to the folders cabinet, then system module, and then cabinet parts. And from here, I'll select the F-shape part. Here, I will choose the element A. As before, I double-click it to open the Add Component window, in which we can adjust the dimensions and alignment. But in this case, I'll leave everything as is and let the software handle the sizing automatically. In the extension section, however, I will uncheck the TB or top and bottom option. This tells the software to attach the element and stretch it so that it completely fills up the space from left to right and from the front to the back, but not across the full height of the cabinet. After clicking OK, the element is placed in the correct position. If we want to adjust the position of any plate within this element, we simply select the plate. The software then displays the dimension lines and available movement directions. For example, if I try to move a panel upwards by changing the top distance from 50 to 0, the software will display a warning. This happens because the space above the panel, the plate, is currently fixed and locked. To allow movements of the plate, we first need to unlock that empty space above it. We do this by selecting the empty space and then we locate the fixed option, which is in the space size section at the bottom of the interface, and we need to uncheck it. Once the space is no longer fixed, we can select the same plate again and set the top value to 0, which now will move it upwards. Finally, we can fill the space below by adding more elements. In this case, I'll use the H-plate option to insert additional horizontal panels and create new segments. This part of the design is now complete, so we can move on by adding a new empty frame to the right side of the cabinet. To do this, we select the panel on the side where we want to attach the new section, and then click the blank frame option. This opens up the Add Component window, and in it, in the Parameter Information section, we enter 900 millimeters for the width, 900 millimeters for the depth, and we leave the height unchanged. After clicking the OK button, the software generates a new empty frame ready to be filled with elements. We begin by adding the left and right panels, followed by the top panel and then the bottom panel. Previously, we used the split space function to divide the lower section, but this time we'll do it manually by repositioning the bottom panel upwards. We click the B plate to generate the bottom panel, and then we switch to front view for better visibility, and we select the bottom panel. The software displays the dimension lines, which we can edit directly. We click on the current value of 2064 millimeters and subtract 80 millimeters, resulting in 1984 millimeters if my math is correct. After confirming the change, the software moves the panel upwards, creating a new empty space below it with a height of 80 millimeters. Before adding the support elements, we switch back to the default view and then select the upper empty frame and begin adding the components. First, I attach a thin back panel using the thin B plate option, and then I select the same space again and click Add Custom Plate, which opens up a new window with options for adding customizable panels: horizontal, vertical, front, back, and top panels. In this case, we need to add a front panel, so I go to the front plate section. Here I make sure the embedded plate option is selected so that the panel aligns flush with the rest of the cabinet. After clicking OK, the software places the panel at the front. To work inside the cabinet, we need to make that front panel, which we just added, to turn it transparent. We do this by selecting the panel itself and clicking the Hide button, which allows us to select the elements behind it. Next, I will select the empty frame again and return to the custom plate option. This time I add horizontal panels. In the horizontal plate section, I choose the number of plates I want to be added and then click the OK button, and the software generates them inside the space. Once we're done, I click the Show All button to restore the front panel back to normal visibility. Now I can select the lower empty space and, just like before, add the support elements from plate, then system plate, and then the common brace folder. Next, I want to create a cut through the cabinet. To do this, I'll select the side where the cut will begin, and then click the chamfer option in the upper central part of the interface. When we click on chamfer, a new window called Corner Cut opens, giving us several options for creating cuts. We can choose between different types, such as from left to right, from top to bottom, from front to back, a center cut, or an angled cut. Each type has its own section with additional settings that control how the cut is applied. In this case, I'll choose the left to right cut, and from the available options I'll select the third preset. After clicking OK, the software generates the cut based on the selected parameters. As we can see, the cut creates an opening in the lower section where the support elements are located. Because of this, we need to add additional supports to compensate for the removed material. I select the lowest empty space and navigate to Cabinet, then System Module, then the skirt board folder. From here, I'll choose the skirt board H element. After double-clicking it, the Add Component window opens up, and here we set the dimensions, the orientation, and its alignment. I'll make sure that the horizontal alignment is set to the left, the vertical alignment is set to the bottom, and the element is positioned at the back of the design. Then I click the OK button to add it. At first, we can see that the dimensions don't perfectly match with the design, so I'll need to adjust them manually. We select each part of the support element individually, and in the property bar under module parameters, we modify these values. For the right piece, I'll adjust the cutting width, and for the front piece, I'll adjust the cutting depth. You may notice the element still doesn't align perfectly, and that's because I didn't account for the material thickness when repositioning it. To fix this, I'll subtract 18 mm from the width value. Now the support elements are correctly positioned, and we can continue with the rest of the design. Next, I'll change the direction in which the cabinet extends by attaching a new empty frame to the front panel of the cabinet's side. I click on the empty frame option and in the Add Component window I enter the dimensions for the new frame, which will be 600 millimeters width, 1200 millimeters depth, and 2100 millimeters height. I also adjust the horizontal alignment to the right, so the new frame lines up correctly with the existing design. After clicking the OK button, the frame is successfully added. Now we can begin filling this new section with elements. An important detail to keep in mind is that Haixun Speed Design places panels based on the current camera orientation. For example, if I select the frame and click the R-plate button, the software may place the panel at the back, depending on how the view is oriented. To fix this, I'll adjust the camera angle so that I'm viewing the design from the correct direction. Once the view is aligned, clicking the R-plate button will correctly place the panel on the right side. With that corrected, we can continue adding the remaining panels. I add the left panel, the top panel, and the bottom panel. Next, I'll adjust the position of the bottom panel, and just like before, to create space for support elements. I'll select the panel and subtract 80 millimeters from its height value, resulting in an empty frame with 1984 millimeters height. This creates a new space at the bottom, and I then will select the space and add a thin back panel. In the lower section, I'll attach the support elements, which can be found in the common brace folder. I add the back support first and then the front one, making sure to set the correct alignment using the front option for the front support beam. I continue by adding door panels to the newly created cabinet. I'll select the empty frame and navigate to Cabinet, then System Module, then the door plate folder, and then the swing door, where we can choose from several predefined door designs. I'll select the two-door option and double-click it. This opens the door plate add window, where we need to configure the parameters across several subsections. The first section, door plate, contains the basic data for the element. In the second section, called hinge, we set the hinge type and all the dimensions for the mounting holes. In the next section, handle, it includes options for handles similar to those we saw earlier in the drawer settings. Here we can see a graphical preview along with dimensions, position, orientation, spacing between mounting holes, and handle type. Next, we have options for frames, as well as the ability to add a lock. If we choose to include a lock, we simply check the lock option and configure the remaining parameters. We also have the option to add a decorative copper strip, and in this case I'll apply the same pattern to both the left and the right swing door. Finally, I return to the first section and select the embedded options so that the doors align flush with the rest of the cabinet. I'll click the OK button and the software adds the doors to the design. Next, I select the newly added doors and make them transparent so that I can access the space behind them. This is done using the hide option, which is located in the upper central part of the interface. Now that we have access to the interior, we can continue adding the elements. I'll select the left section and use the Add Custom Plate option to insert 5 horizontal panels. Then I'll add a clothes rod to the neighboring section to complete the interior. To finish, I'll restore the swing doors to their normal state by clicking the Show All button located next to the Hide option, which returns the swing doors from transparent to visible. Next, after confirming that all the elements have been added correctly and we are satisfied with the design, we proceed with the checking of the design. We'll select the slot and hole option from the top of the interface and click the option Hole Preview, which makes the entire model transparent except for the holes and connection elements. Then we right-click on the empty space next to the cabinet and go to the Check section and select both Hardware Check and Plate Check, one after the other. First, we'll do a hardware check, which automatically scans the design for conflicts between hinges, connections, and fittings. The plate check, on the other hand, verifies that there are no overlaps or conflict between the plates / panels. We click the hardware check button, and the software informs us that there are multiple inconsistencies in the design. These are displayed in a table where we can click the Automatically Modify All button. Then the software will apply the recommended fixes which are listed in the Modify Recommendation column. After applying the corrections, it is advisable to run the hardware check again. If everything is correct, the software will display a notification stating that all hardware is normal. We then perform the same verification for all the plates in the design using the plate check option. If everything is in order, the software will display a plate is normal message, confirming that no other issues were found. Once all checks are completed, we return to the standard view by clicking the solid preview mode inside the slot and hole function. If we want the software to display all the elements currently implemented in the design, we can use the Explode Preview option, which is within slot and hole. To return to the normal view, we simply click Explode Preview again. The next step is to save and export the design for further processing in Haixun Speed Production. We click the Designed button on the far left side in the upper interface, in the upper region of the interface. The software then asks whether we have finished the design and whether we want to save the current draft. We confirm by clicking the OK button, after which a new window opens up where we enter the name and the order number of the project. Next, we need to right-click in the empty space around the design and select the option Edge Bending Solution from the menu. This function automatically adjusts the model to account for all the panels requiring edge bending. Finally, we go to the Production Info tab in the upper part of the interface and select the option Report Form. Using this option, we can export all the design data for further processing. We click the Export All button and we choose the destination folder where the files will be saved. After creating and selecting a new folder, we confirm with OK. This completes the work in Haixun Speed Design. The software confirms that the export has been successfully completed, and we can now import the 5 generated files into Haixun Speed Production for further preparation and parameter setup. Our next step is to launch the Haixun Speed Production software, which is designed for fast and efficient optimization of all the elements of the design. It is necessary to make sure that the USB token is connected with the computer and before we launch the software. Then we double-click on Haixun Speed Production, which launches the software, and we are greeted with its main user interface. The main function of this software is to automatically create the most efficient layout. It calculates the best orientation and position for each element, and then prepares the plates for processing, in order to maximize the use of material and minimize the waste. In the previous step, when we exported the project from Haixun Speed Design, a folder was generated containing a total of 6 files. namely 4 Excel files, in which we have complete documentation with the detailed information about all the elements in the project. We have one BMP image, which is a visual representation, i.e. a render of the design, and one XML file, or the main file that contains all the data for the project and is named according to the name when we entered before exporting. The first step is to select a raw material from the material database. After starting the program, we are greeted with the main working area. In the left part of the interface, we can find the raw material specification section. In this section, we will add the processing plates for our design. We can find them in the material database, which I will check and make sure that all the types of plates which are needed for my design are already added and their parameters are set. From the top menu, I click the material option, and from the sub-menu, I select Raw Material Manage. In the newly opened window, we have two sections, Raw Material Manage and Stock Management. To add a plate, from the top section, we select the type of material for which we will add new plates. And in the bottom section, Stock Management, we click on the new button, which greets us with a new window named Add New Parts, where we need to enter all the data for the type of material that we're adding to the list. Finally, when I enter all the parameters, I press the Enter button and the software informs us that the material has been successfully added. To select the material that we will use for the processing, it is necessary to right-click in the empty space in this selection, and from the option menu, select the Choose Raw Material command. This will open a new window with the same name, which displays all the materials stored in the database. The table shows the following information: the selection checkbox. If the box is checked, then the selected material will be included in the optimization process. We have the material name or type of material, which has the name or type of the material, the length of the board, the width of the board, the thickness of the board, and the inventory and color of the board. As I mentioned earlier, it is necessary that all names, dimensions, and color names are entered accurately without grammatical errors, in order to avoid conflicts during optimization and G-code generation. It is especially important that all names in Haixun Speed Production are completely identical to those in Haixun Speed Design database, including uppercase and lowercase letters, space, and special characters and symbols. After selecting the material, we can proceed with importing the file. To do this, we move to the adjacent section, Board Size, where we right-click in an empty space and select the Import Product Information option from the drop-down menu. When we exported the data from Haixun Speed Design, the software generated several files for us. From them, we need to select the XML file that bears the name of the project. In our case, it is the file named Radek01. When the file selection window opens, the software will automatically display only the XML files, while the Excel documents will not be visible. I will select the file Radek01 and click the Import button. By uploading the XML file, the software will automatically fill in the tables with informations, parameters, and dimensions. The next step is to optimize the layout of the elements. This is done by clicking the Calculation button. The software will start the calculation and automatically generate the most optimal layout for the elements on the processing plates. After the optimization is complete, the program will automatically transfer us to the optimization section. In this section, we get a detailed visual display of the orientation of the elements, their position on the boards, and the efficiency of the material usage. Here we will also select the appropriate tools, adjust the processing sequence, and generate the final G-code. Before we do that, The software offers us the option to manually change the position of any element. And to do that, we can use the following options. The option Move Board, which moves the element to another position on the same board, or we can choose the option To Which Page, which moves the element to another board entirely. Right-clicking on any element opens up the additional menu containing the options for moving, rotating, and reorganizing the layout. If we want to change the order in which the machine will process the elements, the procedure is as follows. We need to right-click the elements and then we select the Check Work Order option. After this, each element will display a number indicating the current processing order. We right-click again and select the Set Work Order option. Then we can manually click the elements in the order in which we want them to be processed. The new order will be defined according to the order of clicking. When we're finished, we need to right-click again and select the Setting Finished option. To enter a new type of material into the Haixun Speed Production database, we need to, in the top-down menu, we need to select the material option, which opens up the raw material command. And in the new window, we can add new materials, edit the existing ones, and delete those which are no longer used. What we also need to make sure is that all of the tools which we're going to use are already added in Haixun Speed Production. To add new tools, from the top menu we select Settings and then we select the option Tool Manage. This opens up the tool management window in which we can manage all the tools from the database. If we want, with the command Add, we can add a new tool. With the command Edit, we can change the parameters of the selected tools, and with Delete, we can delete the selected tool. In the Speed section, we can add the speed at which the machine will process the material, i.e. the cutting or the cutting speed or feed rate. After we've completed all the settings and selected the appropriate tools, we need to generate the G-code file. G-code is an instruction code which tells the machine the direction of movement, the working speed, the tool change, and all other operations necessary for processing. The generation of the code is performed by clicking the Generate G-code button. After clicking the Generate G-code button, a new window named CNC Control welcomes us, where we need to enter the processing parameters. Here we have options for the tools, the order, the speed, and the depth of cutting, and much more. In the first window, named Tool, in the Set Working Tool Speed segment, we can enter the values for the speed of cutting, grooving, and opening holes. And in the adjacent segment, we have the final depth and the value for Save Z. In the third submenu, named Model, we can find the parameters for the tools in the magazine. In this segment, we enter information about all the tools and we predetermine to the software which tool should perform which operation. In the Set Step / Diameter segment, we have columns with the tool number and their diameter. We can notice that before the tool number, we also have a description of the type of operation, such as cutting, where we enter the number of the cutting tool. In my case, I will select the first cutter from the magazine, or T1 or Tool 1, which is an end mill cutter with a flat tip and diameter of 8 millimeters. Immediately below, in the Tool 2 or T2 section for slotting, I will enter an end mill cutter with a diameter of 6 millimeters and will use it for milling. In the section below them, or hole 1 and hole 2, we enter the order of the cutters for opening holes and their diameters. Once we've set all of this up, we can finish the export by confirming the settings, after which the software will perform the operation and the System Hints window will appear, notifying us that the G-code file has been successfully generated. The only remaining thing to do is to transfer the G-code to the machine. We copy the finished G-code file to a USB memory stick and then load the stick into the CNC machine controller, where it's ready to start processing. This was the last step in the preparations for our design. We have completely designed the model in Haixun Speed Design and set all the processing parameters in Haixun Speed Production. The only thing that remains is for us to manufacture our design on the machine. I hope that this video was useful to you and that it helped you in using this software. I'll see you soon in another video. Bye!